Oops. All right. Yeah, Polly missed doing something, so give me a second. There we go. Ah, okay. Good that I started early, so I can still readjust my stream. There we go, and the last. All right, all set. And yeah, it's perfect timing. So let's go ahead and start. Good morning, everyone. And yeah, there's not more special announcements for today because we've already talked about the assignments due end of this week. And so we'll go on and start talking about the subjects today. So first is to wrap up the administrative info. Hi, morning, Callie. Yeah. So feel free to say hi to each other, to me, to all the entire class in the morning, or for the Tuesday session in the afternoon. So we are not yet done with the admin stuff. In fact, today, the videos coming up will be talking about the things that many of you are concerned: grading, okay, how you will be receiving grades. So the first video is to give you an overview. There are actually 3 parts of grades you'll be learning, and these are the 3 parts. Let's talk about how you earn grades credits at the end of the semester. There'll be 100 points to distribute, and they are distributed into 3 categories. So your work here, so by homework I actually meant PAs. So these PAs altogether counts 35%. First one, very straightforward, counts only 3. The others, each counts 4 points. So you see that these PAs are important. Second category is interaction. That includes quizzes, answering the quizzes in an interesting way, as well as participation, asking questions, answering questions asked by other students, or answering questions asked by Polly. Okay. Third category, exams. There will be 3 exams, each 10 points. So you see altogether 35, 35, 70 already. Exam is in fact the lowest weight among the 3 categories. Now this is just another way to break down the 100 points by whether they are teamwork or individual effort. For PAs, you work as a team. For quizzes, you also work as a team. So you discuss, you work on it. One of you represent the whole team and submit solutions. That will be fine. As the individual, participation counts based on who you are. Okay. Teammates don't get extra credits. Exams, this is also individual effort. Each of them have 30 points to earn there. But you see, the teamwork part counts 65 points. Therefore, your team is very important. So you want to find people responsible as well. Okay, so the team can have 2 people, 3 people, as well as 1 by yourself. So loners allowed. The same members, you'll be working as a group throughout the semester. So these are the things you'll be working in a group. Occasionally, I think once in like 3-4 years, there'll be students asking to break up from the team. Okay. That is also allowed. Okay. I thought that would be interesting for you to observe. If you fail to manage your time well, you're dragging your teammates down and they might get angry. Okay. And I would also like those who find their teammates are not responsive and not contributing enough, you get angry, right? You get this emotion. But maybe the teammate was just not very good at managing time. College is a period of time you learn how to manage time and manage emotion. Okay, so I don't know if there will be breakups this semester. We'll see. Well, let's hope not. And let's talk about each of the three categories in more detail. So first, the easiest, the PA assignments. Here's to talk a little bit more specific about each categories that you are earning grades. So homework assignments, essentially PAs. You guys will be working on a Unix workstation that I'll be giving you the user account and the password so you can log on. If you take a look at the PA assignments description, you will see a little bit more how you log on and try and follow through the description to complete the assignment. Okay? And for the socket programming part, you'll be using Golang. All the submissions are in electronic format. From the description, you will see how you submit. Stage 1 is for you to exercise a particular type of socket which is commonly used. It's called the TCP socket. PA1, you just need to log on to a Unix server and exercise the basic Unix commands. So you know how to go places and generate files, edit files. PA2, the first serious Golang assignment. Accessing file, but we are not doing socket yet. Okay, how do you read from a file? How do you write into a file? PA3, now, can you read from a file and upload that file to a server? Or, upload to a server. So you're writing a client to upload the file. The server is waiting for the file to come. Okay. PA4, now, turn around. You are implementing the server side taking files. Okay. And it's a server that takes only one file upload and close. PA5, it's a looping server. That server will stay on, so we could accommodate multiple file uploads, okay, from different clients. PA6 is to further extend the PA5 server such that not only we can take multiple uploads, these multiple uploads can be simultaneous. Okay, so the uploads can be coming in the same time or coming in such that it feels like the files are uploaded at the same time. Okay, it's a concurrent server. So this is a series of assignments, exercises so that you do socket programming. As a result, you are capable of writing client-side of application, a file upload application, and sophistic server-side, okay, of the file upload server, file upload application. Second stage, we switch gear. Golang is a programming language, comes with lots of side libraries. One of them is the web server is already implemented there. Okay, you just need to call the APIs the correct way, then you already set up a web server. Okay, so in this stage, there are 3 PAs. First is for you to write a web request interpreter. So this is to write the web server side after receiving a web request, interpreting the content of the request. The web request is a message coming from a web client. Okay, the server needs to first get it and interpret it. Next, again, progressively in PA8, you finish the second part of the server, which is to generate the file, the web page the client is looking for. So you generate the response. So web response sender, generate a response and send it back to the client. Third, nowadays, hey, there are pretty much no HTTP servers around. All of the servers are HTTPS. How do you make your server a secure web server, an HTTPS server? Okay, so second stage, 9 PAs. Now, just one more thing. For the PAs, there's a PA description. It's a PDF file. You read through it and work on the PA. There's also a set of assistive videos. If you ever get stuck, watch the videos. If you feel Polly is talking too slow, just, it's YouTube video, right? Speed it up to 2 times, 1.5 times, and get to the point you get stuck. All right, now, hey, where are these PDF files? This is the course page, so focus on the upper right corner where you see the gopher. So Polly is scrolling down. Where do you find the PA assignments? You go to the golden link, and here you see all the assignments. Recall, there are 9 of them, right? The first 6, stage 1. It's a general server, client-server application implementation using TCP socket. And the PDF file is right here. So the first one is called the Unix command. So all you need to do is to try to log on to the PA workstation and exercise working on such a workstation. It's a Unix-based workstation. All right. So you will read through the PDA description, and if you have trouble, okay, following the description, you can also follow the videos. So Polly will be describing as well as demonstrating, okay, how you do some of the steps there in the PDF file. Okay, so there's PDF and companion videos that would take you on the journey of finishing the PAs. All right, and you know what? Focus on the center screen, the scoreboard. The PA1 channel, if you click in, you'll see the team accounts will be ready by February 26 noon. You know what? They are in fact ready already. So if you have the team number, then you can just go on and log on and start working on PA1 or PA2, PA3, PA4. The username for your team is s23cn, followed by your team number. Okay, so if you are team number 1, the username is simply this. Okay, the default password. So each of the account is assigned a default password, which is just slightly longer than your account username. Okay, so I kind of just spell out S23's S, Spring 23 CN for team 1. Spring 23 CN1. So this is how you log on. And definitely make sure you change the password as soon as you can, right? And because you do have teammates, after you change the password, write it down and send it to everyone. So all the teammates, make sure that you log on with the new password to make sure, all right? Make sure that it's working for you. And let's see. Okay, so you will see a team number from Polly's response to your quiz 2, which is coming up in about 10 minutes. Okay, and in fact, yesterday I already posted quiz 2, and I see that quite a few of you have already completed it, and this is what you see. Okay, so for example, Mark and Stephen and Wei Chen, they are team number 1. Okay, so they posted the team composition, name and student ID, and answering the Q1, Q2, Q4 on quiz 2. And Polly would assign the team number. So this is team 1, and team 2, team 3. Okay, I mean, Polly started trying to respond to the messages. I guess in the score, the messages, the replies actually go down in the timeline. So the messages are sorted by the timeline unless we create a thread. But I did not allow you to create a thread. So yeah, so I guess I would just assign the numbers, okay, next to what you have typed up. All right, and so see here, Gladhy, I hope that I pronounced your name correctly. You guys are team 2, and Idris, team 3. All right, so given these team numbers, you can start working on the PAs already. Okay, so that's a programming assignment. Now, the second category of assignments you need to complete to earn grades are the quizzes and participation. Now, here's the video to explain. Next, the quizzes. They will just pop up in the middle of the lecture, but these problems are related to the topics we just talked about or we will be talking about. So you'll be given time to work on the quizzes in class. Those straightforward quizzes will be given shorter amount of time. Those that are a little bit more open, that requires creativity and brainstorming, will be given more time. Okay, so you guys try to find your teammate, establish another channel like a line chat group there to have discussion, and type up the conclusion. Type up whatever you have on Slack, and this is what typically students do. There's going to be a channel created for each quiz. Okay, so when I say quiz time, okay, then I'm gonna introduce the quiz, and then you can go see if the channel is right there on Slack and type up your solution there. All right, so post your solutions on Slack, okay, right there in class. Definitely, that's great. We'll talk about the solutions in class. Now, those who prefer to watch videos offline, type up your solution by Saturday, 6 p.m. And this is for the quizzes given that week. Okay. Now, some of you might prefer verbally tell me what you have come up with. It's okay. You can call in using Google Meet and just speak about it. Now, the quiz part of the grade is going to be graded based on completion rate. If you finish 3/4 of them, you get 3/4 of the 25 points. Those solutions, okay, that are thoughtful, unique, and those that are quick and amazing gets extra points. So there'll be 5 extra points reserved to those teams who are particularly creative, particularly thoughtful, particularly quick, okay, at typing things up. Okay. So together, quiz, 30 points. The PAs and the quizzes, they all come with the due date and due time. If you submit late, there's going to be a penalty. And the amount of penalty depends on how late you are. If you are late, only a few minutes within an hour, 10% deducted. Beyond 1 hour, but within 6 hours, 20%. So you can follow this chart here and see that if it's more than 1 day late, all points are taken. Okay, so be careful. Don't be late. Class participation. So there's 5 points towards the semester grade comes from participation. Essentially, all interactions count. Therefore, when you are interacting with me, with other students, identify yourself. So all interactions, including on Slack, on YouTube, as well as email. Right there live during the lecture or offline, okay, all counts. So it's not just interacting with me, but also interacting with the other students. This part of the grade is going to be based on a curve. Some of you might be more active, some of you might be less active. Okay, we'll scale the 5 points across from 0 to 5 to those who participate more versus less. Okay, so there's going to be a maximum point, participation point, and minimum participation point, and they'll be scaled to 0% to 5%. All right, so yeah, I keep saying Slack on the video because we have been using Slack for a while, and this semester it's a little bit new to use Discord. All right, so essentially the quizzes, if you just complete all the quizzes, you get 25 points in the end. Okay, there are 5 points that are when your answers to the quizzes are creative, thoughtful, or particularly fast. Okay, it's not always that we go for the fastest solution. Okay, but usually if you are more thoughtful or very creative, you get those extra recognition. Okay, and you will see that on the grade recording that some of your contribution to the quizzes are recognized. Okay, and those will be counted and count towards that 5 point extra for the quiz. Now there's 5 points that are participation. For example, Kelly there saying morning to all of us. That is actually 1 point, but that is 1 point to all the participations. So again, for the participations, that will be actually we'll be collecting all those and then grade everyone's participation grades in the end of the semester on a curve. Those who are more interactive will definitely get a score that's very, very close, or even 5% in the end. Okay, good. Now, one more video. And this, in fact, is easy. Okay, probably easier than the programming assignments, the exams. Exam. We know that it's going to be in Google Form. The all Google Forms, including the all exams, are all available from the exam link from the course page. Definitely try them out. In addition to working on the Google Forms, most of these questions are in the Q&A form. You will see. You need to also join a Google Meet video session. So you need to have a working camera. You need to have a stable internet connectivity as well. So that at least we could check the picture on your ID. You need to show your ID. We need to see the picture on the ID and your face right there in front of the camera. And throughout the exam, we need to show yourself also shoulder up in front of the camera so we could see that you are busy working on the exam instead of chatting, talking, okay, to other people. There's no early or makeup exam because it's online. You can take it anywhere around the world, okay, as long as there's internet access. Now, in case we find any weird behavior, you receive 0 for the grades, and we report to the department in the university. There's a late submission penalty for the exam as well. If it's late but within 1 minute, 12 points deducted. If it's within 2 minutes but beyond 1 minute, 25 points. Within 3 minutes, beyond 2 minutes, 50 points deducted. Otherwise, all points deducted. So you see that you don't want to be late for the exams, that the penalty is really, really high. And so where do you find these all exams? Again, from the course page. Click into the exams. You will see descriptions that Polly just said in the video. Okay, so the rules, and you need to have a camera ready there, and that's pointing to your head, shoulder up during the exam. And there are Google Forms you need to fill. And so for those who have never done exams over Google Form before, definitely try some of these earlier exams that are in Google Form out. Okay, so you could fill these out and get a feel how it's gonna be like. Okay, and you know what? All the past exams are available with solutions available as PDF files from this part of the exam page. So when it's time closer to the exams, definitely go to the exams link and find out more. Okay, and there's just one more video before we end the admin information, and that's spend more time with quiz 2 next. So this video only half a minute. It's just to tell you what the textbook is and the references are. Last is just the class material. There's a textbook. It's the very classic computer network top-down approach book. We'll use the 7th edition. There's an 8th edition, but the difference is just very little. So let's stick to the 7th edition. The goal and assignments, there's a reference book. It's freely online. The PDF is accessible from the course page. Slides in PDF format available from the course page. Videos on YouTube also available from the course page. Everything else on Slack. And if you cannot find them, just ask. All right, so, but you know what? Let me just go back a little bit. Yeah, so videos on the course page. It's in the lectures link, so that will take you to all the video collections we have. In fact, let me come back here. Yeah, if you click into the video link, you will see all these short unit videos, okay, including what's coming up today: terminology, chapter flow, the physical view of the internet, etc. Okay, so that is if you feel that Polly talked too much and you feel like studying yourself. but having those short videos will help. Then you can do it this way. Okay. And by the way, what's nice about having a course online like this is you don't need to get up early in the morning like today. It's perfectly fine that you study on your own later on in the day. Try to, however, participate in the score discussion, because you might miss the chat discussion already if you are not here in the morning. Okay, so there are ways that you can make up for participation for quizzes. PAs and exams are very free. You just need to submit on time. Okay. Let's see. Slides. Where are the slides? There's a slides link here. Okay, so click. These are where the slides are. Okay. Everything else will be on the video I said Slack, but this semester they will all be on Slack. Good. Now, quiz number 2. Form a team of 1, 2, 3. After that, work on answering these questions. Can you write poly email messages in Chinese? This we covered yesterday, right? That's in the features, right? The course is 99% English. What is that 1%? Okay, so Q1, can you send poly emails or messages in Chinese? Q2, what exact day is exam 3? Okay, so this is also yesterday, right? That's in the schedule part of the video. Q3, how much penalty for PA number 1 if you submitted March 4th, 180001? Now that I think is covered today, earlier, in the PA video. Q4, can you type up questions in Chinese in the live YouTube video sessions? Yeah, that's actually very related to Q1, isn't it? When can you use English and when can you use Chinese or Mandarin? Okay, so form a team of 1 to 3, answer these 4 Qs. So under the score, quiz 2 channel, make sure that you type the name and ID of your teammates and the answers to Q1, Q2, Q3, and Q4. Now, let's go to the Slack space. On the Slack space, at the top of the channel, you see definitely the same question. Okay. And you see that some of the teams already posted their answer, particularly Team 1 and Team 2. Actually, no, Team 1. Team 1 actually posted in a way that it's a picture. But Team 2 somehow managed to type, right, multiple lines in one message. How did they do that? Yeah, Gladys, I hope you're here. Can you teach the rest of the class? And I think Team 3 copy probably Gladys' answer and then edit the answer on their post. So Idris, I guess that's what you did. Okay, and I see Team 4 and 5 did the same thing. Of course, you can copy, right, like this, and paste. Interesting. Interesting, very interesting. Oh, Stephen. Okay, Jian. I hope that I pronounced your name correctly. Correct me if I'm wrong. Okay. Yeah, exactly. So there are 2 solutions. Gladys said that he actually typed it up on a notepad and copied the whole thing and pasted it onto the score. And Stephen there, as well as Jian, I hope that I pronounced correctly. Sorry, I feel really, really bad if when I mispronounce people's name, because I don't like people pronouncing my name. So Gladys, if I am not pronouncing your name quite correctly, and Jian, if I did not did it right, let me know. Okay, definitely let me know. So you hit the shift and press answer. That take you to the next line instead of sending out your message. Very good, Stephen, Yijian. How can I find a group? Miguel, go log on to the score. You will see many of you guys go on the random channel and introduce themselves. Okay, and those who are introducing themselves and trying to form team, maybe the 2 or 3 of you can just, I think there's a very good demonstration, right? So Mark there, taking initiation, right? Because Franklin here posted, hey, I'm a student, I'm looking for a team. And then Mark said that I'm also looking for a team. And then Mark said, hey, how about the 2 of us form a team? See? Easy, okay? You openly approach another one. And by the way, guys, in this class, no discriminations. Be kind, okay? And you try to take on your responsibilities being a team member, all right? And the others, Zhen, okay, thank you. Okay, thank you, Yuzhen. Perfect. There you go. There you go. Very happy to see you guys. Yeah, just, be open. Say it that I'm looking for a teammate. Okay. Or, hey, we have 2 people. We can take 1 more. Okay. Oh, and by the way, I get a question yesterday, but somewhat offline. Some of you might not be sure that you would get into the class. Okay. So when people invite you to join their team, that your teammate know that I might not be able to get in. So the other teammates are mentally prepared. Okay, and by the way, we can always merge or split the teams later. All right. So it's not a thing that you must make sure that you are in the class in order to join a team. And those who are inviting people to join your team, they might be in, but they might not be in. So you want to be prepared. Having a 3-people team where 2 of them are sure in the class, that might make you feel more comfortable. Then you try to select people to add to your team such that you are more comfortable, right? And you know what, guys? You are allowed 10 minutes to do this. Okay, so take your time. And those who already formed team, maybe you guys can start connecting with each other, establishing maybe a line group or something else. Okay, so that you guys can easily message each other, okay, or talk to each other. And once you have done that, you can start talking about, all right, so how do we distribute work, right? And hey, PA assignment is doing the first one coming up next week. Maybe you guys can talk about how you do that. And some of the teams I know, everyone likes to do your own version of the PAs. That is great. And so maybe underneath your team account, you want to create some subdirectory so that each of you can work in your own space. But in the end, you guys need to agree on which one's solution will be posted according to the PDF description so that Polly can check. Okay, all right. And so currently it's 10:53, so we'll resume the lecture 11:03. Okay, take your time, and let's work on quiz 2. right. Okay. So to answer the question, so for the workstation, if you are within NTU, you don't need to VPN. But if you are outside of NTU and trying to connect to the workstation, so let me go back up a little bit. So the next topic, of course, is coming up, chapter 1. But maybe I can stop here by explaining just a little bit, okay, for access to the workstation. So definitely try to patient to read through the whole thing. So first thing is to get an account, which you already did. And the IP address of the workstation is right here. Now there's a firewall on this workstation, and only students coming from within NTU campus. So it's gonna check the IP addresses of your connection, of your machine. If it's within NTU, you'll be able to connect fine. But if it's outside of NTU, you'll be blocked. So the trick to get around this problem, in case you need to connect from outside of NTU, is to VPN to NTU's VPN service. Okay. I think you can look it up like this: NTU Computing Center VPN service. Let's see. Yeah, so it's NTU SSL VPN. I think this is the English page. And this is how you install first a client to connect to the VPN. I think you will need to somehow enable your VPN account. So let me see if there's a more general. It's Chinese. So hey guys, if you know how to get an account so that you can log on to NTU's VPN and the instruction is in English, could you post it on Discord so that everybody knows? Mm-hmm. Yeah, I think this is for the definitely for Chinese. Since a few years back, in order to get VPN service, you need to apply to the computing center. But it's quite straightforward. You just log on somewhere and then click a button, and then, okay, you're getting. I think we need to. Yeah, every one of us need to get that authorization to use VPN, according to the Chinese description. The English description appears a little bit shallow. Let me see if I can find. Nah. I am sorry for the international students because sometimes it's not very easy to find information in English. VPN installation guide, but again in Chinese. Yeah, this is just Chinese entirely. Oh, I think okay. Once again, Gliding here came to the rescue. Okay, so let's see. Yeah, so it was the page I found earlier. Yeah, I guess you click into this link and follow the instructions. Step 2, enter the rightmost 4-digit number of your ID. Yeah, and if you have trouble, you can call them up. Okay, good. So we should have that VPN issue addressed. All right, great. Good. So now finally, okay, we can move on to chapter 1.1, okay, the opening. This video is a little bit long, so we do have 5 minutes left to the break. So here's what I would suggest. Maybe we take a break now, and we'll resume the lecture at 11:16, and we'll start talking about computer networks. So let's take a break. It's 10:16. I'm sorry, 11:16. So let's go on and start talking about computer networks. So the first video is actually trying to clarify some terms that we will see very often throughout the semester. And Polly want to, make sure that each of them sounds very clean what they meant to you guys. All right. So here's the video. It's a little bit long, about 8 minutes. All right, this is chapter 1, introduction. Well, before we introduce what is internet, let me bring up these terms: human, calculator, computer, system, device, network, communication, information, and data. You see already, right? Some of the terms are very similar. Kind of, you can easily associate them. But some of the terms, if you look at them as a pair, they are somewhat different. Now, if you're asked to try to group these terms based on similarity, feel free to define what you think, how you define similarity. Okay, so let's take some time. I think it's probably not that hard to associate terms. For example, calculators and computers, very similar, just slightly different on the functionality, right? Device systems, seemingly general, but they all kind of refer to a sort of engineered, machinery. But what about network? Is network the same as a device? Or similar to a device? I think starting from there, you guys might be thinking a little bit differently, right? From individual to individual. Well, whatever you guys are thinking, let me show you what Polly's language IQ is. Okay, so what I see, based on my background about computer networks, I kind of think that human, calculator, computer, system, device are all entities. Okay, and by the way, Polly's language IQ is not always the highest. Well, you know about Polly, not very good in terms of, language expressing in terms of words. Okay, so I think these human, calculator, computer system, and devices are all entities. And one can actually associate these entities and form a group. For example, all of us, some of us know each other, we form a network of humans. And you could actually try to connect the calculators by Bluetooth interface, for example, then you end up with a network of calculators. Right? If you connect a group of computers, then you have a network of computers, network of systems, and a network of, for example, wearable devices. Okay, and if we exchange information over the group of associated entities, then you are communicating this group of humans or this group of computer systems or device. And the stuff, we're communicating over such a network are the information or data. So we send data or information, and these are the things we communicate over the network of computers. All right. So they are somewhat different and allow Polly to try to classify them into these entities, grouping of entities, the function of the group, and the content. We are actually applying function on among this group of entities. All right, now think human network. And if we define a human network by how we know each other. So if you guys now know Polly, then you guys are connected to me, right? So you know how to go on Slack and send Polly a direct message. You know how to send Polly a direct email. How about you guys knowing each other? Right? If you guys know each other, then you also have a connection between the two of you, right? So you guys are not just connected to Polly, but some of you are connected to each other. And all of us here sitting in the classroom, we also form a human network, right? Then that should make it a little bit easier to think what is a computer network. it's a network of computers. You guys will probably be saying, right? Intuition says so. You are actually mostly right, okay? But allow me to clarify, in this course, it's not exactly right. So again, in general sense, it is a network of computers, right? Based on our, language IQ, right? Because computers, if we connect them together, it is a network of computers, right? Literally. But in a professional sense, in this course, okay, when people say, or if you read in the textbook that you see this term, computer network, introduction to computer network, but we actually meant more specifically the internet. And this internet, a lot of times we call it computer network, but we also call it this, the data network. So computer network, data network, what else? Sometimes, right, information network. Let me see. Sometimes also this, communication network. Okay, so they all kind of refer to internet. Okay, but computer network and data network are more specifically to internet. Communication network in professional speaking can also be, for example, 4G net or the telephone network. Telephone network was the old network where you have these wire phones and you just talk to each other instead of texting each other. Okay, so communication network is a little bit general. Okay, while data network very specific. Okay, professionally speaking, the internet, same as computer network. All right, and just to clarify, but okay, judging on the words, computer network, it is a network of computers. And it's actually referring to a network based on the entities involved. Data network is a network that transmits data. So data here is actually referring to the network based on the content, the stuff, okay, being transmitted. And communication network here is referring to a network because of the function of that network is to allow communication. Okay, so entity, function, and the content, okay, that we're passing or connected as a network. So in other words, okay, you can also define, create your own computer network, not just the internet. So there could be internet version 2, 3, 4, and on, okay? But those other networks will not be the computer network, the internet that we're using, all right? So you probably see a little bit where Polly is going. The objective in the long term is so that you guys are trained, so you could create your own network that will work better and serve better the need of the people, okay? Especially people that will be living in the future. But in the short term, let's start from learning, okay? The most popular example, the internet. And that takes us to the beginning of chapter 1. All right, so next video, somewhat long, but not as long as the terms. I hope that it's clear now, right? Computer network, it meant internet in this semester, in this course. But generally, when people said computer network, it could be like, generally a network of computers. And guys, what you learn in this class is about the internet. But that doesn't mean that you cannot be creative and design a better mechanism that works for the computer network in the future, right? Good, so chapter 1.1, let me, actually chapter 1, let me go over the sub-chapters, okay, in the first chapter. So the flow of chapter 1. The goal in chapter 1 is so that you guys get a rough idea, get a feel of how internet is like. There'll be a lot more depth and detail later in the course in chapter 2, 3, 4, and 5. And so you will see, right, this being the overview of everything, much of the content you'll be hearing in this chapter will be more descriptions. Okay, so we have this part that's called the edge of the internet. We have that part being called the core of the internet. Yeah, so you just hear a bunch of terms, and then there'll be a little bit more elaboration on other terms. And much of the content concerns internet, but we'll also talk about parts that, communication networks that is not quite called internet and pre-existed before there's internet. Good. And the flow of the chapter is this. We'll start from giving you a nutshell of what internet is in a few slides, like 3-4 slides. Okay, so it's like a crash course. Okay, if you really need to explain to your classmates or other friends, you're taking this course and what is the internet like? Yeah, that will be the part that you tell them what internet is. Now, in that part, we'll give you the physical view of what the internet is. But with just the infrastructure, we cannot be sending emails to each other. We cannot be chatting online through Line or through Slack to each other. So there'll be some rules we need to define how the data are being exchanged, how these computers or entities on the internet interact with each other. So there'll be some rules we need to learn as well. And we call a set of rules controlling a certain mechanism, defining a certain mechanism working on the internet, a protocol. Okay, there'll be a lot more coming. And then these two will be actually to further, zoom into the nutshell view of the internet and to give you a little bit more idea how the edge is like and what are the varieties of the edges could be. And then we'll talk about the core. We'll talk about the core. Yeah, this is actually the part that's hidden. They exist, it's just that we don't see it. Okay, there are lots of very expensive routers. They are interconnected, passing data in really, really high speed. So up to this point, you should get a rough feeling of what the internet is and how it's, working in general. Now, the rest of it, so these are the things concerning internet and that we are supposed to care, as engineers who might be redesigning internet. So we care about how the internet perform in terms of data loss. Certainly, we don't like to see a lot of data losses. We care also whether it takes a lot of time to send data. Hopefully, we will be able to send data with short delay and things like that. And we'll talk about, protocol again. There are quite a few protocols that we use actually sending email, browsing the web every day. And there's actually a very special way we group also protocols. So earlier you heard Polly trying to exercise you a little bit more and trying to link certain terms together. You know what? The protocols, because there's so many of these, it's actually better that we kind of structure or sort of group the protocols so that it's a little bit easier to talk about. And the way network engineers group the protocol is so that we kind of divide them into layers. Within each layer, they are associated, they are similar in a certain way. So that's also called the service models. So it's actually a model that network engineers communicate with each other, classifying protocols into different layers. And then this is nowadays something that we care very much, security. Particularly network security. How do we make sure that the data being transmitted are not hijacked, are not hacked, and the secrets are not unveiled? All right, so quite a few things that we need to talk about in the overview, but generally, think of it this way. They are hardware components, so individual hardware entities. And then there's software components, essentially the protocols. And these softwares running on the internet are implementations of these protocols. Good. By the way, in the video, I said that we'll talk about internet under attack or network under attack. Due to the time constraint, we'll skip that in the lectures. But the unit videos talking about what attacks that we might be experiencing frequently these days, those are in the video link. So if you're curious about security issues, go there, check that video out. And now let's start by looking at the first video about the hardware part of the internet. Now, what is the internet? So this picture that I'm showing is a very coarse-grained view of the internet, where you can kind of see that this part being the ISPs, internet service provider. All there are in these ISPs are just these cylinders with the cross, indicating that this is an exchange. So ISPs, the machines in there are mainly there to do data exchange. And then you guys are here. Most of you guys are here. In NTU is an institutional network where you might be accessing the internet through wireless AP. So this is Wi-Fi. Some of you might be sitting in the dorm and having wired connection, having a PC accessing through wired connection. And some of you might be sitting at home, then your laptop connecting to Wi-Fi AP, and then connect to your ISP, and then to the rest of the internet. Now, some of you might be sitting in a cafe. That would be nice, I know. And then you guys are probably accessing the internet through your 4G network and watching the video on the laptop. That is a mobile network there you are accessing, or you can just call it wireless network if you want. Okay, so this is just saying that there are a number of different ways, a number of different kinds of access to the core of the internet. Now, in a little bit more detail and give you the full nuts and bolts view, so meaning the components. So first of all, you see the entities we're using as users are all these, okay, computing devices, PC, server, wireless laptop, smartphones. Okay, and these things are called hosts, or more professionally, end systems. Okay, we don't just call them systems because there's one common feature among these special hosts. They are all kind of sitting at the very end of this huge internet. Okay, end systems, very edge of the internet. And then, as I mentioned, right? So whatever machine you're using, whatever end systems you're using, you're connected somehow, right? To a cellular tower, right? To a Wi-Fi AP, to a institutional switch. Okay, so inside NTU, there are also a number of these routers exchanging data because we do have several departments, right? So you see typically institutional networks, there are a few more level of hierarchy than the home network, than the mobile network. But some of you could be accessing the NTU PEEP, a wireless network to the internet, all right? So these access networks, what I meant by access network there are not really there's a network, okay? Really, they are communication links, right? So if it's wireless, then we are using a radio link. If it's wireless and through a satellite modem, it's a satellite link. Now, if you're connected from home, chances high that it's a fiber link. Now, if you are connected through Ethernet I know for sure is copper link. All right, so these are different communication links we might use to access the internet. They can be wireless and wired. Now, these different access link or communication link technologies are all slightly different in terms of this, the transmission rate, the number of bits they can transmit per second, BPS. Now, in this course, computer networks, we also call this transmission rate the bandwidth. It actually meant more the width of the communication band, okay, of the network band. Now, this is somewhat different from if you take electromagnetic wave courses when we're talking about, oh, there's certain frequency band in the EM waves that we're using to transmit modulate bits. Okay, so bandwidth there is also referring to the frequency band. But here, the bandwidth, we actually refer to the network channel band. All right. At the abstract level, it's also a band, but we actually meant the band of slightly different things. And last, very important entity. Most of us don't see a router in our everyday life. If you want to see one, I don't know, check out these videos released by Google and showing their data center. All these, slim boxes there is a router, okay? And they are running all the time, passing data, forwarding data in really high speed, okay? And by the way, I'm actually saying the routers forward packets because on the internet, the data are usually divided into chunks, okay? And these chunks are referred to as packets. So later on, you'll see me saying data packets or data messages. Okay, I actually meant things that are similar, all right? So routers, well, there's just one thing, routers. Of course, these routers are manufactured by a different company, so therefore there are different brand names like Cisco, like D-Link, yeah, lots of them. Juniper, there's another one, a major one in the States.
All right, so generally you see that ISP kind of more internally inside the internet are these routers. And then between the routers and the end systems will be these machines that you use quite often daily. Now between the end systems and the routers, you have the what? Access networks. And access networks are not really networks. They are the links connecting the core and the edges. Now, I understand. So I've watched the video like a million times, and every time I read the textbook, this part of the textbook, it was kind of boring because it's very straightforward. Yeah, but you see, a lot of times you need to know these basic things before you could be creative or innovative and add additional things onto the internet and make sure that it still interact with each other. And so the next video is to introduce these new generations of end systems called the IoTs, the Internet of Things. Now check out these weird things that you might be seeing, you might see showing up in the market.
All right, so let me say a little bit more about the end systems with this slide. Laptop, PC, servers, smartphones. These are the things we typically use to connect to the internet. But nowadays, if you go to these electronic shops, if you go do a little bit shopping on the Amazon or PC Home, you see there are these generation of new things coming along, and they can all be connected to the internet. They're called these IoT, the Internet of Things. Yeah, things is a very general term because these things don't have a specific form. So they could be internet capable toaster, internet capable power meter, internet capable mattress, internet capable fridge. And this is a picture frame. Okay. So for example, Watt. This is a smart meter that connects to the internet, and this meter can actually take the reading and go on Twitter and tweet the reading itself. So you can imagine that the power company, power suppliers, energy suppliers can just take the readings from Twitter without taking a trip, okay, to your home. Smart mattress, right? So this mattress can sense how you sleep overnight and provide some feedback to you. This can further be made into something that's a little bit robotic, not just being capable of sensing, and so try to adjust the firmness of the mattress so that to ensure you have a good sleep. Smart fridge, I always like to have one of these. So it actually takes, there are cameras inside, so they take actually photos of the milk. So sometimes when I was in the grocery shop, I would really like to know whether I should be buying milk today. So this smart fridge will be able to remind us, okay, when we're in the grocery shop, whether it's time, okay, to buy milk. Picture frame. I think this is one of the very, very old IoT device. It's connected to the internet, and it was using a way that, hey, so you guys can send recent pictures through these IP frames to your grandpa. So you give these IP frames as a gift to your grandma, and so that every day they kind of see different pictures from you. Now this one is Polly's favorite. It's a smart toaster. So what it does is that it will go on the web and retrieve the weather, okay? And so when you're making the toast, you kind of burn the mark corresponding to the weather today. So as you're eating it, you know the weather seamlessly, okay, without needing to check on the web. Nice, isn't it?
Yeah, I look it up and see if I can buy a toaster like that, but no, yeah, it's not commercialized. All right. Yeah, and so last video is to sum it up. Given that picture that Polly showed earlier with the routers, okay, towards upper right, and then the end host lower left, and then access network connecting them. you see that it's a network, okay, but it's actually not a strict hierarchical network.
And so those covers kind of all the components that's composing this very coarse-grained internet. But on top of the physical structure, there are also these rules, okay, that's controlling sending, receiving of the data, right? Such as, this is probably the third time that I talked about this term, TCP. HTTP is the protocol, the set of rules, okay, overwatching how you send data over the web. Yeah, so pretty much for each of the service, there is a specific protocol. For each type of service, for data transferring, there's a specific protocol. And so you see in general, the internet is a network of networks. So this is what? A network of a subnetwork, right? So institution network is a network. Home network is a network. Global ISP forms a network. Regional ISP forms a network. And the internet is actually the bigger network of all these smaller networks interconnected each other. And it's loosely hierarchical. Why? If you look a little bit closer, yeah, this mobile network is connected to actually a higher tier ISP, while this home network and institution network is actually connected to a lower tier, a regional ISP. Okay, so it's not necessary that the mobile network is, level 2 or level 3. Okay, in this case, it's actually level 2 at the similar level as the regional ISP if, they share the global ISP. All right, so this is what I meant here. It's loosely hierarchical, right? And there are parts of the internet being public, okay, meaning everyone involved, okay, in the society, in that region, okay, they will try to donate and to take part in contributing the expense of running that public part of the internet. But for most part of the internet, it's now private. So for NTU, an institutional network, to access the institution's ISP, usually we pay, okay? Similarly, at home, you pay the ISP for access. Similarly here, if you're using 4G, yeah, you pay someone to get access. So these, as long as you're paying, that means you're accessing a private network, okay? There are occasionally public network, not a whole lot, but usually public network, the reason that we don't pay is because essentially we are contributing part of the work, okay, sharing part of the cost already, okay, by forming a consortium and paying a specific membership fee.
All right, so that loosely hierarchical network of networks, that is actually the most concise way of describing what the internet, the physical structure, look like. Okay. Now we switch gear a little bit. Okay, given that we know it's a loosely hierarchical network, let's talk about the software running on top of it. Okay, the service view.
Now the service view. Okay. To explain, we've learned, right, the nuts and bolts that's composing the physical internet. That is the communication infrastructure to allow us to actually have these applications sitting at the very top at the first place. But the communication infrastructure on its own will not be allow us to send data really that freely. So we could do surfing, we could send emails to each other. Between the apps and the infrastructure, we still have a number of these communication services defined by these protocols, okay, that's running on each of the devices, running in these routers. Okay, so there's a software component, a service component there as well. Now, two major classes of services that are provided by the internet are these: reliable data delivery versus the unreliable data delivery. Okay, so internet, essentially, it's not just a physical infrastructure, but also an infrastructure with software support so that we could run all sorts of distributed apps on top of the whole thing. There's just one thing I want to clarify. For unreliable data delivery service provided by the internet, a lot of times we just call them the best effort service. Yeah, I know it's a little bit counterintuitive because reliable data delivery is obviously better than the unreliable data delivery. Okay, so why calling the unreliable service the best effort service. Yeah, take note here. We're saying this is best effort service. We're not calling it the best service. Yeah, this is a kind of a polite way of saying that, hey, there's no guarantee. If you recall cases where your friend's asking you for favors, but you know, are not, you know that you don't have time for it already. So a lot of times what you say to your friends, right, politely, is, I'll try my best. Okay, so that's what we meant here, calling these unreliable data delivery services the best effort services.
All right, so yeah, we are all trying our best, I have to say. Now, so that's get a rough idea of what the softwares are like. So it's some services, we call them services or protocols that are running. Some of these protocols would do a reliable transmission, but some of these protocols do best effort, trying their best transmission, meaning unreliable transmission. Okay, and then given these basic services, then we run applications on top of that. Okay, now so let's talk a little bit more about this term, protocol. Okay, I've talked about it several times today, right? So exactly what they are, what it is.
This is so that I can impress you more about this term protocol. It is a slightly more formal way of calling a set of rules, okay? Calling a standard way of parties communicating with each other, all right? So two very simple examples I'm giving, and you know, as analogy to another. One on the left is a human protocol, okay? One asking for another person for information. The other is an internet protocol. One end system asking another end system for information. So you see here, very often when Alice wants to find out what is the time, she says hi, right? And then maybe a friend here catching, you know, Alice needs a bit help. Bob says hi back, okay? Showing that, okay, what do you want to know? Alice says, have you got time? And Bob provided the information that Alice is looking for. Similarly, we as users might be sitting in front of a desktop using a web browser trying to get the content from this URL. So yeah, that browser sends a message to the web server that holds the content. And that server will say, sure, you got my attention. What are you looking for? Client sends, I'm looking for this page. And server sends back the content, okay, of that URL is indicating to. So that is a simple protocol in human world and in the computer world. To sum it up, a protocol, it can be a human protocol or a computer protocol. Okay, so that example you just saw is for Alice to ask Bob for a time, a client asking for a server for certain information, or for you to ask a question. For example, if you raise your hand, right, that's like you saying hi. And if Polly noticed that, Polly says, okay, good, what is the question? Then you start by asking the question, Polly answering the question. So that is the protocol to get a question answered. Okay, so for people first meeting each other, how do you introduce each self to each other? Yeah, so there are specific protocols that allowing human to communicate with each other. Okay, so they are usually involving specific messages and specific actions taken after the messages are received, right? And then so on and so forth, right? You know what? That's very similar in the computer network, okay? And the parties involved are just simply replacing humans with machines, okay? And so all these communications happening in the computer network, okay, are governed by these protocols, where we define messages being exchanged and the orders of them being exchanged and the actions each of these computers, each of these entities, okay, need to take after receiving certain messages.
And that takes us to quiz number 3. And before we start, there was a question on the chat channel. So Miguel was asking, Is there an example of best ever services? Yeah, if you think the postal service, the registered mail will be guaranteed delivery, right? It's reliable service. And the regular mail, there's no guarantee, but most of the time they will arrive to the receiver. So it's a best ever. In fact, on the internet, okay, there are two types of services to transmit messages. One called TCP, the other UDP. TCP, the one starting with T, is the registered mail, the reliable one. UDP, well, it starts with U. Think of it as the unreliable one. Okay. We'll talk about these two services in chapter 3, the transport layer. Okay. Now, quiz 3. Okay, so Polly likes to read. I don't know whether you guys like to read. So Polly reads randomly, broadly. So there's this article Polly ran into in Wall Street Journal back in 2013, 10 years ago. I think still today, how you greet each other, how you get to know other people. Is there like a standard protocol or the most efficient protocol? That is still a question. Okay. So that article's title is The Delicate Protocol of Hugging. So, I mean, hey, in Taiwan, we don't hug. Okay, I can't hug my dad. Sorry about that. I do hug my mom. Okay, so you see that human intimacy, okay, for different cultures can be very different. Okay, and for different individuals can also be very different. But Western cultures, you know, okay, sometimes I do have trouble saying whether I say we do hug a lot or because yeah, I do have somewhat split identity. Okay, partly Eastern, partly Western. So I mean, in the US, I do hug. When I was living in Europe, we do hugging all the time and touching on the cheeks all the time. Mm-hmm. You see that when you are in different culture, you hug differently. You greet each other differently. Okay? So Americans hug a lot. I hug with my neighbors, my colleagues. Okay. Latinos, Europeans, mostly kisses or touching the cheeks. Be careful. Sometimes it's 2 times, 1 on each side. Sometimes it's 3 times. Okay, and it can be also a little bit tricky which side you start. Japanese bows. Okay, generally. I'm not sure if I really shake hands with Japanese. I think I just bow. Okay, that seems to be the most appropriate thing to do. Okay, but I think generally for most culture, and even if we are traveling in foreign countries, shaking hands is a way of showing being friendly, polite. Okay, if you're not quite sure what to do. And some of us, I think, at least for Polly, I've been traveling quite a bit and going different places. What I do to be polite is I wait for others to try to initiate greetings. And I guess for girls, it's okay. Okay, for ladies, it's okay. We're expected to be a little bit more reserved. Okay, but when I'm running into other girls, then I might be a little bit more aggressive aggressive in a way that I try to show that I'm passionate about meeting you. Okay, as I try to encourage you guys being open on Discord. Sometimes you will find that it's not a bad thing. It might look a little bit stupid for Eastern culture people, but it's actually not. Okay, getting to know people, even random people, is always helpful. Okay, you learn something new. I understand that you might run into strange people every now and then, and it gets awkward, and you don't like particularly that kind of awkwardness. But hey, learn to like that. I Holly nowadays enjoy all these awkward moments. I actually started thinking, how come, right? There are these awkward moments. How can human communication, human exchange be awkward? So obviously there are some sort of mismatching there, but why? Why? Well, hey, I don't know exactly why. I'm still pondering. So for quiz 3, however, okay. And by the way, answering quiz 3, then you may go. Okay. So question is, oh, by the way, hey, as I said, right? Poly being a girl, being a lady, I can be a little bit reserved. But you see, if you try to be, if you are reserved and not try to show you're sincere, you're passionate, again, things get awkward, right? So if you are a guy meeting a girl and you hesitate and not, showing that, not initiating greetings, what will be the impression for the girl? Probably not that good either, right? But hey, too aggressive, freaky. So you see, it's tricky, isn't it? It's delicate, as the author, as the reporter of Wall Street Journal put it. Okay. So general question here. How do you know if you should bow, shake hands, hug, or do the kisses on both cheeks? Okay. I mean, we are all techies, technical people. Or some students are probably not strictly from the EE or CS departments, but maybe from the engineering departments. Even if you are from the economics departments, do you know, right? Do you know how to greet people? And can you come up with an algorithm? That would be the easiest. When you're running to people, then you can just follow your algorithm. Okay. So can you come up with an algorithm to greet people? If you think about it this way, hey, it can be a part of chat GPT, right? Because it's transforming human intelligence into something that you can use easy for everyday tasks. Okay, so teams, find your members, chat with each other, come up with your own algorithm to greet people. And you have 10 minutes to work on this. All right. So I already see many of you typing up your solution. So for example, Team 2 say, we can ask, where are you from? Okay, do you mind? Right? Do you go by hugging or just shaking the hands? Okay, very outspoken. So Team 2, good for you. Miguel? Okay. Yeah, so you might be in a party, right? So you get to observe how others in the party greet each other. Interesting. In NTU orientation, you check out how other international students greet the domestic students. Yeah. And Team 7, based on the subtle body language cues. Wow, okay. Hey, I have to admire Team 7. I'm never very good at this, body language cues. Okay, I'm becoming more sensitive to facial expressions, but body language is not exactly easy. But I do know that some of you are very good at this. Eye contact and hand gestures. Wow, magic. So you see that my reply to Team 7's answer, magic, sure. Isn't that magic? Body language. Let me know who else in the class can pick up body language this well. 医生. Okay. I think you meant Team 11. Sorry, I gave you a 10 and another 1. So please add the two numbers out, please. And Team 8, Jack. Depending on where we are. Okay, because in the article, right, it says for different regions, the greetings are done differently. So you can do a location-based algorithm. Okay, in US, hug. In Europe, and depending on which country in Europe, you can also have a finer granularity algorithm. And Team 5. Which one is the... okay. How about just be yourself? Whichever way you like, you just do it. Yeah, so this is a very, be yourself solution. But I think this is one solution generally speaking, but Team 5 says, for them personally, and coming from Asian background, you prefer shaking hands. Okay, there seems to be less awkward moments that way. I know in Asian society, being too close is a little weird, isn't it? But how can we be weird being close? How do we feel weird being close? I don't know. Do you understand? I'm not quite sure if I understand. So I don't know. I'm actually not quite sure. If you do know, message me. Maybe DM me. If it's a little bit complicated. Team 3, we observe the other's appearance and guess their nationality. Oh well, I hope that I am able to do this as well. I did find that I was wrong very often. Do you guys backpack? You might want to do that. Okay, backpack through European countries. And then you will see that you are very often wrong if you guess by the appearance. Let's see, Mark. Oh, Mark, that's a little bit arrogant of you, Dream Team. Okay, but let's see. Public documentation. Okay, so this is a very engineering solution, right? You look up the web and find if there exists an algorithm to greet people. That is cool. That is cool. Okay, I know. I think it's a legitimate solution, but more seriously, you predict the way. So maybe you try to predict if you fail, you take that as an input, and you do human learning continuously, right? It's a semi-supervised human learning. If you think you are the one who should initiate, go forward the best with best guess. Yeah. And team 9. Oh, hey guys, by the way, time is up. But I do enjoy reading you guys' solution. So, but time is time. Time is important. So, the time today is up. Polly will continue on with the stream and go over the rest of the team's solution. Those who have appointments and you need to catch up, or you are already super hungry, feel free to go and catch up with your friends. So with that said, I say bye. Okay, bye. So most of the time I do this. Hey, part of me is probably more American or European. We do greet. And we are polite and saying these greetings at the time that we're supposed to each other. So bye. Okay, just like in the morning, I say good morning. Okay, bye. Thank you for your participation too. Okay. All right, so let me get amused continuously by you guys' solution, Team 9. If the state of ourselves isn't appropriate to greet. Okay. In case you're sweaty, I understand. Okay, bye. Is there an option for office hour? The office hour. Okay, that's a good question. Bye. Yu Zhen. Okay. Bye, Chloe. Bye, bye, Ting Jun. Bye, Meng Jie. I hope I'm right. Okay. Bye, Li Qiang. Office hour. MA 77. Okay. Agent 77. We do have an office hour. The office hour is actually now. Okay. You're free to call in from the call-in session. That's a Google Meet session. And I'll be able to answer questions if you have any. But the YouTube session is not off yet. So hope that you don't mind waiting for a little bit until I finish going through the quiz solutions. Okay. Yeah, bye Brian Bing Cheng. Oh, that's a very interesting name. Okay, I should probably not pronounce that, otherwise we might get a warning from YouTube. Okay, and Zerei and Idris. Okay, and Bingcheng. So if we are sweaty, yeah, we should let them know. Else it depends on the culture and the sign from other people. Yeah, so location based plus guessing the nationality plus I guess gestures, body language, right? 多累. Okay, I hope I'm pronouncing your name right. All right, and Ragiriel. Rockreal. I always watch your videos. It gives oh, you're welcome. I hope I pronounced your name right. Rogerio. Very Italian. You're welcome. And Zerei will nod first. Okay. Yeah, a gentle nod, showing that you're friendly. Okay, and then that's a way of inviting. the other side to say something back or do something. I actually like this. Okay, subtle but elegant. And 敬仰. The real Team 10. Yeah. You are the real Team 10. Very good. Humor. Hey, humor is the best thing in the world. First, do the safest option, shake hands. If you see them trying, to be closer, you let them hug you, okay? If switching failed, you look like Eastern people, so okay. It won't be offensive, I understand. Thoughtful. You think about the consequences if you do it that way. In Team 6, 心和. Just shake your hands first, do the least intimate greeting, and see how the others respond. Safe solution, very safe. Glotty, I think the greeting method doesn't always based on location, but somewhat greets by others in a common way in some area. Interesting. We could now conclude, can use the universal protocol. I see. Glotted is like, if this is C programming, you have a switch, right? And then you could have layers of conditions you check. If in the end, right, none of the condition match, you have a default shake hands. And the location, if it's just the current location, it might be a bit tricky. Yeah, I understand, because some locations are public, some locations are a little more intimate. And so depending on where you are, not depending on which country you are, things can also be a bit different. So guys, turned out that just to greet each other, it's so complicated, isn't it? And it's not easy to come up with a perfect solution. Yeah. Okay, so we have pseudocode here for quiz 3. So very interesting, you guys. Okay. Where are we? If US. Okay, so hey, this is if else type of pseudocode. If people are hugging, hug. Otherwise, say hi. So you wave and say hi. Else if Latin America and Europe, if they try to do the kisses on the cheeks, then you do the same. Else say hi. In Japan, if they bow. Otherwise, say hi. I see. So this is like an implementation of Glottis solution. I've got to know exactly how you pronounce this. Glotty. I guess H is silent. Glotty. All right, great. So yeah, that's it for the video session. And Mr. 007, you may call in now. Okay, I see you. Oh, by the way, next Wednesday. Okay, I need to post somewhere and let everybody know. Okay. All right. Bye. Ending the stream.